This is one in a small number of videos where I take a look at some strange and/or difficult A-level chemistry calculations. So here's the question. We have 20 cubic centimeters of a hydrocarbon, which we can call CxHy, exploded in excess oxygen. The total volume of gases after reaction was found to be 50 cubic centimeters lower than at the start. On bubbling through sodium hydroxide solution, a further contraction of 80 cubic centimeters occurred, with all measurements made at 20 degrees C and 1 atmosphere pressure. So which of these answers is the correct answer? C2H4, C2H6, C4H6 or C4H8? So you might like to pause at this point and give the question a go yourself. There are at least 3 or 4 concepts that must be understood in order to be able to answer this question. Well, the correct answer is C, C4H6. If you didn't get that, here's how the question is done. I've represented here my hydrocarbon as H/C. The hydrogen will react with the oxygen to form steam, which will condense to form water at 20 degrees C and 1 atmosphere, and the carbon reacts with oxygen to form CO2. Now here's one of those concepts that you must be aware of. Sodium hydroxide solution will rapidly dissolve the CO2 gas. So that 20 cubic centimeters of hydrocarbon is resulting in the formation of 80 cubic centimeters of CO2 because of that contraction in volume. Here's the next principle. First of all, we can reduce those ratios down to 1 cubic centimeter, producing 4 cubic centimeters. And I'm going to apply next Avogadro's principle. Equal moles of different gas occupy the same volume under the same conditions of temperature and pressure. And in applying that rule, I'm able to say then, if 1 cm cubed produces 4 cm cubed, then 1 mole will produce 4 moles. That means then that we've got 4 carbons in 1 molecule of this hydrocarbon. So next we need to find out how many hydrogen atoms are in 1 molecule of the hydrocarbon. And of course we need to keep an eye on all of these volume changes. So let's consider how the formation of CO2 from the carbon in the hydrocarbon, reacting with the oxygen present initially, will adjust the volume, if at all. So we see from the balanced equation that 1 mole of carbon reacts with a mole of oxygen to form a mole of CO2. Now we have 4 carbon atoms in a molecule, so let's multiply by 4. And you can see that to react the 4 moles of carbon, you'll need 4 moles of oxygen. But at the same time, that 4 moles of oxygen that's used up will be producing an equal number of moles of carbon dioxide. That then means that the burning of the carbon in the hydrocarbon with oxygen to form carbon dioxide, while it uses up oxygen, it produces an equal volume of CO2 and therefore does not of itself affect the volume. The 50 cubic centimeters reduction in volume that's mentioned in the question has 2 sources. First of all, the hydrocarbon itself, when we have 20 cubic centimeters of the hydrocarbon which completely burns, the disappearance of the hydrocarbon accounts for 20 of the 50 cubic centimeters reduction. That means that the remaining 30 cubic centimeters can be accounted for in the use of oxygen to burn the hydrogen in the hydrocarbon. So we know that specifically 30 cubic centimeters of oxygen reacts with the hydrogen in the hydrocarbon. So let's see what we can elucidate from that. But before proceeding, we must bear in mind that we divided by 20 up at the top right there. So I do need to divide the 30 cubic centimeters by 20. So that will give me 1.5 cubic centimeters. And again, applying Avogadro's principle, that's equivalent to 1.5 moles of oxygen. So we know that 1.5 moles of oxygen reacted with the hydrogen in the hydrocarbon. Let's look at the equation for the reaction of hydrogen with oxygen to see how many moles of each are involved. And you can see for every half mole of oxygen, you react 1 mole of hydrogen gas. So I would like that to read not a half O2 but 1.5 O2, because that's how many moles of oxygen we've established have reacted with the hydrogen. So there's the appropriate equation. And of course now we can see that there must be the equivalent of 3 moles of hydrogen molecules, in other words 6 moles of hydrogen atoms, in one molecule of this hydrocarbon. So that's it, we've established that as well as 4 carbons in a molecule, we have 6 hydrogens. So the formula is C4H6. The correct answer is C. Thanks for listening, and do consider looking at other questions in this series.